Hello there, this is a geometry video. It is chapter 10, section 4, and today we are discussing inscribed angles. And so to get started, we have some vocabulary for you. An inscribed angle has a vertex that is on a circle, kind of like vertex R right here that we see in the diagram, but that also contains chords of the circle as the sides. So here you can see that the side of this angle is RQ, which is a chord of the circle, but also RS is the other side also on the circle. So those are two chords that make up the sides of the angle. And of course, angle R is the vertex. So in circle C, angle QRS is said to be an inscribed angle. An intercepted arc has endpoints on the sides of an inscribed angle and lies in the interior of the inscribed angle. So in this case, in circle C, the minor arc, which is QS from here to here, is the intercepted arc, and it's intercepted by angle QRS. Alrighty, there are three ways that an angle can be inscribed in a circle. So we have the three cases here, case 1, case 2, and case 3. Case 1 is where center P is on a side of the inscribed angle. So you have it going right to the diameter there. And second case is center P is inside the inscribed angle. So you see that the center is inside the actual angle. Or in case 3, it could be outside the inscribed angle or in the exterior. And we have a theorem. It's called the inscribed angle theorem, theorem 10.6. And it says that if an angle is inscribed in a circle, like angle 1 here, then the measure of the angle is equal to 1/2 the measure of its intercepted arc. So this angle will equal 1/2 the measure of the intercepted arc. Or if you wanted to go backwards, you could say that the intercepted arc is twice the measure of the angle. So you have that here in equation format, and you can see both directions there. So we're going to use this information to do our first example. And it says here in example 1, find each measure. And so in part A, they want us to find the measurement of angle P. And if we look at our diagram, you can see that angle P has an intercepted arc, which is MN, which is 70 degrees. So we are going to have that the measurement of angle P is equivalent to 1/2 the measurement of the intercepted arc, which is MN, and so then we replace the MN with 70 because that's what the diagram says it measures, and 1/2 of 70 is 35. So lo and behold, the measurement of angle P is 35 degrees. In part B, we're going to go backwards. They're giving us, or they want us to find the measurement of the arc PO. So here's arc PO, and as you can see from the diagram, PO has an angle, the intercepted arc has an angle of 56 degrees. So when you go backwards, we say that it is twice the measure of the intercepted arc, which is PO. Sorry, I said that right and wrote it wrong. That's not good. So what we're going to do here is we want 2 times the measurement of angle N. So if we go backwards, then this measurement is going to be twice as big as the 56 here, which is angle N. So we're just going to go over here and replace the measurement of angle N with 56. And if you double 56, you get 112 degrees for the measurement of arc PO. And that is how you do that. So now you can attempt to do example, or do it yourself number 1. Right here below, there's a part A and part B. And then we will move on to our next example. And for our next example, we have another theorem. Theorem 10.7 doesn't have a special name, but the theorem states that if 2 inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. So you can see over here that we have this angle DBA in red and the angle DCA in blue, and both of those angles have an intercepted arc of AD, which is this green portion here, and because they intercept the same arc, those 2 angles, angle C and angle B, will be congruent angles. That's basically what the theorem is saying. So in example 2, they want us to find the measurement of angle T, and we are using this diagram. And so the first thing we notice is that angle T has an intercepted arc, which is SV, But angle U also has the same intercepted arc of SV, and because they're the same intercepted arc, then we can know that angle T and angle U have the same measure. They're congruent. So since we know that angle T is 3x minus 5, we can set up an algebraic equation where we equate 3x minus 5 and 2x plus 15, because we know that the measurement of angle T should equal the measurement of angle U, because they have the same intercepted arc. And now this just becomes a straightforward algebra problem. So if we combine our x's and move our constants to the other side, all in one swift step, 3x minus 2x is x, and 15 plus 5 is 20. So we get that x equals 20. However, they didn't only ask us to find x, they asked us to find the measurement of angle T. And angle T is 3x minus 5, so we need to replace our x with a 20. And then we get 60 minus 5, so the measurement of angle T is equal to 55 degrees. Now you can do it yourself number 2, and then we will go on to our next example, and it's going to be a little bit of a doozy because of course it's a proof, and you guys hate proofs, but I'm going to walk you through it, so let's not cry, at least not yet. All right, so example 3. Write a 2-column proof, and it has our given and our proof statements. So there are going to be 6 steps here, so you're going to want to make sure that you have enough space for 6 steps in your notes, so it's not all crowded together. Or maybe you don't care, I don't know. But we're going to write our statements. It's been a while since we've done a proof, so hopefully you haven't forgotten everything. But when we write a proof, we generally start with the given statement and then see where that carries us. So for our first statement, we're going to start with arc JM is congruent to arc KL. And that's pretty much given. Now, one thing I should have done, I'm assuming that you're doing it, but we shouldn't assume anything. So what are they even asking us to prove? We do have a diagram over here, so I want to just kind of briefly direct you over to the diagram so you can see kind of what's happening here. They want us to prove that triangle JMN, so this triangle right here, congruent to KLN, which would be this triangle here. So these two triangles, they want us to prove that they're congruent. So we're going to do that because we know that when you have intersected arcs that are congruent, their chords are congruent. So we know that JM is congruent to KL. We have some vertical angles here, and then we also have angle M with an intercepted arc of JK, and we have angle L with the same intercepted arc of JK, and when that happens, angle M and angle L are congruent. So just by talking to you about this, we can already see that it's going to be angle side, but we still have to get it on paper, or in my case on the board, so you can actually see the steps. So the first thing we're going to do is say that JM, which is now a chord, is congruent to KL. Now this is actually Theorem 10.2 on page 715 in your textbook, but it was like a couple sections ago. But it basically says that 2 minor arcs, which these are minor arcs, they're less than 180, are congruent if and only if they're corresponding, let's see if I can get this all on here, corresponding in chords are congruent. That's actually the theorem, and because it doesn't have a special name, you can't just write Theorem 10.2, you have to spell it all out. So again, we see that JM is a minor arc and KL is a minor arc, and since they are congruent, their chords are congruent, which is what we're saying here. JM is congruent to KL. So all of a sudden we have a pair of sides that are congruent, and we needed that for our circle. For the next thing, we're going to say that angle M and angle L intersect the same arc, which happens to be JK. Okay? So you can see that here, angle M, this angle here, and angle L have the same intercepted arc, which is JK. And that's by definition of an intercepted arc. That's what it is, definition of intersected arc. Lovely. All right, so now in step 4, I'm trying to color code so we can separate the steps from each other, because it'll all become a big blur. Because they intersect the same arc, then that tells us that the angles are congruent. So angle M is now congruent to angle L by theorem 10.7, which we just had before example 2, which basically says that inscribed arcs angles. Inscribed angles, where's my eraser? I wanted to use a symbol there. Inscribed angles of the same arc are congruent. I'll abbreviate status like that. Inscribed angles of same arc are congruent. So that's step 4. And then we're getting really close because our last step before we actually go ahead and prove this is the vertical angles. So we can see here that these two angles here are vertical angles. So we have that this angle is congruent to that angle. So you can see your angle and your side now. And now we're going to go with these vertical angles and call those congruent. So that's going to be angle JNM. Angle JNM is congruent to angle KNL. And the reason for that would be vertical angles. More abbreviations. Yay. And then lastly, now that you have your angle, side, you can finally prove that the two triangles are congruent. So we're going to put triangle JMN is congruent to triangle KLN. And it's going to be angle, side. And don't forget your lovely Helmos. Extra credit, yay. All right. So there you go. That is how we do that little proof. So now you are going to have a proof of your own to do. And I'm sure you're going to start crying pretty soon right now. But don't do that. Just try your best and we will go over it in class. But there's do-it-yourself number 3. And then we have a couple more examples, but we also have another couple theorems here. So theorem 10.8. An inscribed angle of a triangle intercepts a diameter or semicircle if and only if the angle is a right angle. So the only way for there to be an inscribed triangle with an intercepted arc that's the diameter is if it's a right angle. So basically here's your intercepted arc, but it goes through the diameter or a semicircle, right? It's half a circle. And the only way for that to happen is for this angle here to be a right angle. That's what they're saying. So example 4, they want us to find the measurement of angle F. Well, since this is going through the diameter, then that means that this angle G must be 90 degrees. And they're telling us that this angle F is 4x plus 2, angle H is 9x minus 3, and what we know is that all of the angles in a triangle should add up to 180. So right now we have that 4x plus 2 plus 90 plus 9x minus 3. All three of those angles combined should add up to 180. So we have a nice little algebraic equation there. So if we add up our x's, we get 13x. If you add up the 2 and the 90 and the negative 3, you're going to get 89. Or at least you should. If you don't, then something's wrong. Subtract 89 from both sides. You get 13x equals 91. When you divide that by 13, x actually equals 7. They didn't ask us to find x. They said find the measurement of angle F. Angle F is 4x plus 2. So 4 times x, which is 7, plus 2, which means 28, plus 2, which means 30. The measurement of angle F in this case is 30. Please exit quietly and avoid the camera. So now you can do this do-it-yourself number 4. And then we'll go to our last theorem and our last example. Theorem 10.9 is our last theorem, and it basically states that if a quadrilateral, which is a four-sided polygon, if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So K and M add up to 180, L and N add up to 180. Hopefully you remember that supplementary means 180, complementary means 90. So in this case, they are supplementary. So in example 5, it says that the necklace charm shown here uses a quadrilateral that is inscribed in this circle. They want us to find the measurement of angle A, which is this angle here, and measurement of angle B, which is this angle here, which is 2x minus 30. This angle down here is x. So let's start with angle A first. And so the measurement of angle A plus 90 has to equal 180, because these opposites, A and C are opposites. So I don't know if you can tell, but this is actually marked as a 90-degree angle. So that's why I'm putting the 90 here. So A plus 90 should equal 180, which obviously if we subtract 90 from both sides tells us that the measurement of angle A equals 90. For part B, we have somewhat the same scenario, only this isn't marked 90, this is marked x, and this one's marked 2x minus 30. So we're going to say 2x minus 30 added to x should equal 180. And we get our algebraic equation like that. And so when we combine our x's, we get 3x minus 30 equals 180. If we add 30 to both sides, then we're going to get that 3x equals 210. And when you divide by 3, x actually equals 70. But again, they don't want us to find x, they want us to find the measurement of angle B. But the measurement of angle B is 2x minus 30, or basically 2 times 70 minus 30. I'm running out of space here, which will equal 2 times 70 is 140. 140 minus 30 is going to give you 110. So the measurement of angle B is going to equal 110. Alrighty? And that's how you use that theorem. So in do-it-yourself number 5, you will go ahead and find the measurement of angle x and the measurement of angle y. And then once you do that, you will have completed your notes for this lesson. And I will see you in class. And thanks for watching.